It appeared out of nowhere, silent, invisible, unstoppable. A fragment of another star system, cutting through the dark like a cosmic blade. At first, astronomers thought it was a mistake, a ghost track, a glitch in the data. But it wasn't. It was real. It was moving too fast, on a path no comet from our solar system could ever take. This was no ordinary object. This was interstellar. Its name, 3I Atlas. And now, after months of tracking and simulations, we finally know the moment it will make its closest dive into our sun. The precise time this alien visitor will reveal its true nature. This isn't just a date. It's the culmination of one of the most remarkable discoveries in modern astronomy. Because when 3I Atlas reaches its perihelion, its closest approach to the sun, it will be pushed, heated, and stripped of its outer layers, exposing the chemistry of another solar system entirely. For astronomers, that's priceless. This moment could unlock the origins of comets, reveal how solar systems form, and maybe even give us a glimpse of what other stars are made of. The countdown has begun. October 29th, 2025, at exactly 11:44 UTC. That's when 3I Atlas will reach its perihelion, its arrival date, the peak of its journey through our solar system. And to reach that conclusion, scientists had to trace every flicker of light, every data point, and every gravitational nudge that shaped its path. But before we get there, let's rewind. It all began on July 1st, 2025. The Atlas telescope in Chile, part of the Asteroid Terrestrial Impact Last Alert System, spotted a faint, fast-moving speck beyond Neptune. It was heading sunward. Within 24 hours, the Minor Planet Center confirmed what many suspected. This object wasn't bound to our sun. Its speed, its trajectory, everything pointed to an interstellar origin. It was the third confirmed interstellar object ever observed, after 1I Oumuamua in 2017 and 2I Borisov in 2019. A third visitor, a messenger from the stars. For weeks, the world's telescopes turned to it. The Hubble Space Telescope tracked its fading trail. The James Webb Space Telescope peered deep into its icy glow. Ground-based observatories across the world contributed to refining its orbit. With each observation, its path became clearer. Then came the big breakthrough. Orbital modeling revealed that on October 29, 2025, at 11:44 UTC, 3I Atlas would reach its perihelion, a distance of about 1.36 astronomical units between Earth and Mars. Some calculations round it to October 30th, but the best-fitting data converge on October 29th, 11:44 UTC. That kind of precision, down to the minute, is extraordinary. And it's not just trivia. Knowing the exact time of perihelion allows observatories around the solar system to synchronize. Telescopes on Mars, Venus, and orbiting satellites will all aim at this object during its most volatile phase. Because at perihelion, comets flare to life. Sunlight heats their surface, vaporizing ices and releasing gas and dust, forming a tail millions of kilometers long. And for an interstellar object like 3I Atlas, that's when its secrets are finally exposed. But here's the catch. From Earth, we won't see it. Around late October, the Sun sits directly between us and the comet. The Earth will be in solar conjunction, meaning the object is hidden behind the glare of the Sun. For that one critical week, our planet is blind. So the task falls to others: Mars orbiters, Venusian probes, and the JWST far beyond Earth's shadow. And that's just the beginning. On October 3, 2025, 3I Atlas will pass within roughly 30 million kilometers of Mars. That's close enough for Mars orbiters like ESA's Mars Express and NASA's MRO to capture direct images. A chance to see an interstellar comet up close from another world. Then, after perihelion, it will swing within 0.65 AU of Venus on November 3rd. And finally, in March 2026, it will pass near Jupiter, just 0.36 AU away. That's where things get really interesting, because some scientists believe we might actually intercept it. A recent paper proposed a bold maneuver, using the Juno spacecraft, currently orbiting Jupiter, to perform an Oberth maneuver, using Jupiter's gravity to slingshot Juno into a trajectory that intersects 3I Atlas in March 2026. The math is insane, a delta V of about 2.7 kilometers per second. But if it works, Juno could fly within thousands of kilometers of the comet, far closer than any telescope ever could. It would be the first spacecraft to approach an interstellar object directly. But timing is everything. If the orbit is off by even a few minutes, the opportunity vanishes forever. That's why confirming the perihelion date, October 29th, 11:44 UTC, is critical. But what exactly will we see when it arrives? Early JWST data already revealed that 3I Atlas is unlike anything we've ever seen. Its coma, the gas and dust halo surrounding its nucleus, is dominated by carbon dioxide. Normally, comets from our solar system are water-rich, with CO2 making up only a small fraction. But 3I Atlas seems to be the opposite. Rich in carbon dioxide, poor in water, and already outgassing even at enormous distances from the Sun. NASA scientists describe it as leaking water in deep space, something no other comet has done. That suggests 3I Atlas formed in a very different environment, maybe in a colder outer disk of another solar system, where CO2 and CO could freeze solid before being blasted into interstellar space. It might carry trapped isotopes or molecules that simply don't exist in our own solar neighborhood. And when it nears the Sun, those exotic ices will vaporize, releasing a chemical fingerprint of its home system. There's also a chance it could break apart. Many comets do near perihelion, especially those with weak porous structures. Oumuamua, our first interstellar visitor, didn't outgas at all, puzzling scientists. Borisov, the second, behaved like a classic comet. 3I Atlas sits between them, partly active, partly stable, unpredictable. As it heats up, astronomers expect violent jets, outbursts, or even fragmentation. If that happens during conjunction, we might not see it in real time. Only after it re-emerges from behind the Sun in mid-November will we know if it survived. By December 2025, it will pass at its closest to Earth, still a safe 1.6 astronomical units away, too far to see with the naked eye. But in telescopes, it could still glow faintly as it recedes into the black. Then, by early 2026, it will slingshot past Jupiter, leaving the solar system forever. It will never return. Think about that. In just a few months, a piece of another world, maybe older than our Sun itself, will come within reach of our instruments. It's a once-in-a-lifetime event. 3I Atlas has traveled for millions, maybe billions of years through the interstellar void, carrying chemical memories of another sun, another system. And for just a brief instant, a few months in late 2025, it will flash through our sky, share its light, and vanish. At 11:44 UTC, October 29th, 2025, that's when the journey peaks. The alien comet at its closest, a frozen messenger passing through our star's domain. We can't see it directly. We can only watch its effects, feel its data, sense its presence. But the fact that humanity can track it, predict it, and possibly intercept it, that's astonishing. It shows how far we've come, from watching comets with the naked eye, to plotting the exact second an interstellar traveler meets our Sun. 3I Atlas is more than a comet. It's a message, a relic flung from a place we'll never visit, carrying materials that predate our world. And when it leaves, it'll take with it a story of cosmic connection, the silent exchange between stars. So yes, the arrival date is finally revealed, October 29th, 2025, at 11:44 UTC. The moment the third interstellar visitor crosses our solar threshold, invisible to the naked eye, but monumental in meaning. Because one day, another will follow. Maybe closer, maybe visible. And when it does, we'll be ready, with new telescopes, faster probes, and a better understanding of what these visitors truly are. Until then, all eyes remain on the clock, counting down to the moment when an alien world brushes against our own, and then disappears into the infinite dark.